Okay, for this second video today, this is really just going to be building on what we learned on the first video and also the stuff that we learned yesterday. So again, this is a lot to write, but if you guys pause the video, just take a minute or two to write this stuff down. This is really similar to what you're going to see on your assignment today. Okay, so when you're ready, we have our givens. Okay, it gives us 1 to 3, 1 to 3, 1 to 3, so it looks like all of our boundaries are the same. So that's good. It's telling us the value of x squared dx, x dx, and dx, okay? So how does that help us? So these first three questions are actually really similar to the last video that we just did, so I'm going to breeze through these first three. I'm going to take more time on these last two, okay? So this first one says x squared dx. Well, if I look up here, x squared dx, you would think that it's this. However, always take a look and make sure your boundaries match, okay? 1 to 3, 3 to 3. Well, remember, if it's just a single point at the number 3, there is no width to that rectangle. So your answer is 0, okay? So let's take a look at this one. X dx, so let's look it up our menu here, see if we have an x dx. Okay, we have this one right here. That's x dx. Let's check our boundaries, 3 to 1. 1 to 3, so it looks like it's backwards. Remember, when it's backwards, we change the sign. Okay? This last one, my boundary is 1 to 3. Okay, these are all 1 to 3, so that's good. What I would do, though, is I would take this constant and pull that to the outside and say 5 integral from 1 to 3 of x dx, because obviously I don't have 5x dx up here. It doesn't show up anywhere. But if I pull that 5 out, and now I have x dx, now that does show up here. So essentially what that's telling me is it's 5 times 4. Okay? So that's going to be 20. Okay? Now for the bottom two that you haven't really seen before. The reason these look a little bit different is just because you're adding or subtracting multiple terms together. When that happens, the best thing to do is to use our addition subtraction property and just separate this into different integrals. So I'm going to say 4x squared on this one. Now I'm going to write plus, and now I'm going to write my separate integral from 1 to 3 of 7. Actually, I forgot to write my dx here. Sorry. Dx. Okay, that's actually pretty important. You want to write the dx at the end because that's going to show up in your menu. Okay. So now once I've done that, I can look at each one of them separately. Okay, so this one I've got a constant right here. So if I pull that constant on the outside and rewrite this as 1 to 3x squared dx, now that looks like something that I can find, right? X squared dx is all the way up here, and I have that. Okay, plus I'm going to pull the constant out on this second one as well, 7 from 1 to 3. Now all I'm left with here is a dx, okay, which is fine because if you look at the top, I have just a dx right here, okay? So I've got everything good to go. I'm just going to have to do a little multiplying. So 26 over 3 times 4, okay, that's going to be 104 over 3, okay? So 4 times 26 over 3 is 104 over 3, plus, this is 7, obviously, integral from 1 to 3 of dx is just 2, so 7 times 2 is 14. Now, we want to get exact answers today, so let's not get decimals and start rounding. Let's get exact answers. Just to save time on this video, I'm just going to tell you, when you take the common denominator here, you end up getting 104 over 3 plus 42 over 3 equals 146 over 3, and that gives me an exact answer. Okay? All right, let's try this second one. Let's divide this up. So I'm going to go from 1 to 3 of negative x squared dx plus 1 to 3 of 4x minus, whoops, forgot my dx again, minus from 1 to 3 of 3 dx. Okay, so again, let's just look one at a time. This first one, it looks like I have an x squared up here, so all I really want to do is take that negative out to be my constant, so that's going to be like a -1 on the outside. So I have from 1 to 3 of x squared dx, which is good. I have that. I'm going to take the 4 on the outside of this second one, from 1 to 3 x dx. And it looks like I'm going to have to take the 3 out on this last one, from 1 to 3, and I'm just left with dx. Okay, so we know x squared dx is 26 over 3, so this just becomes -26 over 3. Okay, we know that x dx is 4, so that becomes 4 times 4 is 16 over 1. We know dx is 2, so 3 times 2, 6 over 1. And again, just to save time on this video, the common denominators here would be -26 over 3 plus 48 over 3 minus 18 over 3. To get an exact answer, this would reduce to 4 over 3. Okay? All right, here's what we'll do. I'm going to give you a U-try, so I'll have you guys write this down, pause the video, and I will pick this back up and give you guys the answers here. So pause the video, try it on your own and see what you get, and I'll give you the answers, okay? So this first one says x to the third dx from 6 to 2. Okay, well this one goes from 2 to 6, so all I have to do is change the sign, -320. That's my final answer. Let's see, this one also goes from 6 to 2. So this is couple steps here. I'm going to take this on the outside. So this is the same thing as 3 integral from 6 to 2 of x dx. X dx is 16. Okay. However, the 16 uses 2 to 6, but we're going 6 to 2. So I'm going to make that a -16. And that becomes -48. So if you got -48, you got that right. Okay, now this last one, again, it's just going to take a little bit of work to chop this up. This would be 1/2 x to the third dx minus 2 to 6, 8x dx plus integral from 2 to 6 of 1 dx. Okay. Now, when we break this down further, we've got some constants we can pull out. So this is 2 to 6, x to the third dx, which is good. That shows up at the top of our page. I'm going to take the 8 out, and that's just going to be x dx, which is also good. That shows up at the top of our page. And this, the 1, makes no difference. You really don't need the 1, so I'm just going to write dx. Okay? So 1/2 times 320 is 160 minus 8 times 16 is 128 plus 4. When you do that all together, you get 36. Okay? As always, let me know if you need any help today.